Hey guys, hello everyone and welcome to the channel. Now today in this particular video we are going to discuss questions which were asked in physical chemistry portion, and we will be talking about section C, that is 4 marker questions. Okay, so these questions are going to be a little different kind of questions which we have already discussed in our previous videos, which were of 2 marker. Their questions are quite direct, but here we need to know a little bit of more detail, and the questions are going to be little intense, right? Now 4 marker question from physical chemistry, and this paper I have taken from the all India exam which happened on 15th of December 2019. Okay, so this is the date of the paper, and this is not the Assam and Meghalaya region question paper. So yeah, this is what it is. Now one more thing before going into the complete solution of it, let me just tell you that the paper contains around 20 to 21 questions from physical chemistry portion, and it's difficult to if it's difficult to make everything in a single video, because it will take a lot of time, a lot of data will be there to upload it, and it will be little difficult for me to handle this big file, right? So what I'm going to do is I'm going to make this video in 2 parts. This is going to be the first part where I'll be taking around 10 questions, and in the next part I'll be taking the rest of them, right? Now this is going to be very important video if you are preparing for CSIR-NET, because some questions were very good in this particular exam. And one more thing, that it was said that physical chemistry portion in CSIR-NET was asked of a very average level. It was not asked of a little difficult level, but yet you will find that there were some questions which needed a lot of attention, a lot of knowledge of your subject. Okay, so let's quickly begin with it. And before starting the video, let me just tell you that if you have not subscribed to the channel, do subscribe it. If you like this video, give it a like after watching this. And one more thing, that if you have not watched the previous solutions which I have already posted for inorganic and physical chemistry of part B, so you should watch them. I'll be posting them in the I button. Okay, so you can just click over there and watch them. Alright, so let's quickly talk about the first question over here, which is from the physical chemistry part, and it says that the rate constant of the second order reaction, the reaction is given to you that 2A is giving you as a product Z is K2. Okay, so K2 is the rate constant, and it says that if the initial concentration of the reactant is A naught and the concentration of the product at time T is X, then the linear function of T with the slope K2 A naught is, okay, so you need to find out that this has to be the slope, okay, and this has to be one of the function. You need to find out the other function. It says that it's a linear function. So before solving it, or before before explaining this, let me just tell you that what this linear function means. It means that when you write down an equation of a straight line, that is y is equals to mx plus c, these are called as linear functions like y and x. So one of the value is given to you, the other one you have to tell. Okay, so now you have to manipulate the data, or you have to just write down the equation in such a way that it just converts itself into this form. Okay, so the equation we know for a second order reaction is given by this, that is K2 is equals to 1 upon A T, and it's given by x upon A minus x. Okay, so that's what we know. Or A, you can write down that's A naught, because the A is the initial concentration, X is the amount of that. Okay, let me just tell you that what is actually happening. So 2A is getting converted into product. So initially when the time was 0, at that time there was A moles of A over here in the reactant, and there was 0 moles of product which was formed. At certain time T, your X amount of your product has been formed, and what amount of reactant will be remaining, so that will be A minus X. Okay, so that's what we know now, so we'll use that to solve it further. So these are the conditions, and this is the final final equation which we will get after solving this. So the derivation of that is not needed to be explained, I guess, right? Now you can just solve it in this way, that is A, K2 and T, and that will be actually equal to X upon A minus X. All right, I'm using A in the question, they have taken it as A naught, so we'll replace it at the end, right? So don't get confused with that. Okay, now if you see this particular equation, like if you just compare it through a particular equation of y is equals to mx plus c, so what you can write down, that if you take x on that, like if you take the time on the x-axis, so basically what you can relate to it is y is equals to mx. Okay, and the intercept will be 0 over here. So if you just compare with that, you will find out that x is actually your time and this is your slope. Okay, so the slope is what? The slope comes out to be k2 and a, and since they have taken it as a naught, let me just replace it as a naught. Okay, so okay, fine, let's replace it with a naught everywhere. Okay, so it will be a naught. Okay, so yeah, k2 a naught is going to be your slope, and this is going to be one of the variables. So what is the other variable? So the other variable will be x upon a naught minus x. So that's how you got the second variable. Okay, or whatever it is asked, that the linear function of t with, okay, so with which you are plotting it. So you are plotting it against x upon a naught and minus x. So this was pretty simple and pretty straightforward question. Let's look upon the next question then. All right, this question was one of the very confusing question. Many people made mistake over here. It says that the degeneracy of the state having energy 27 h square upon 8 ml square for a particle in a three-dimensional cubic box of length L is. Now, for a particle in three-dimensional cubic box of length L is given by this particular formula, that is h square upon 8 ml square, and in the bracket you have nx square plus ny square plus nz square, where you the value of nx, ny and nz you put as the degeneracy values, right? Sorry, you put as the number of particles in each directions. All right, so since you have 27, so basically what you have to relate to this, so it is given that 27 h square upon 8 ml square. When you relate it, when you relate both the things, you will find out that nx square plus ny square plus nz square should be actually equal to 27. So you need to just find out the value of nx and y and nz. Now you can have one of the set of that, that is 1 square plus 1 square plus 5 square, that is going to give me 27. Okay, so 115, so nx, ny and nz can be 1, 1 and 5, and that is going to give me 1 plus 1 plus 25 is going to give me 27. Now you can have three different sets out of that. You can have 1, 5 and 1 also, and you can have you can have 5, 1 and 1 also. Okay, so these are the three sets of values of nx and y and z which will give you 27. Now people just did this and they marked option 3, but there was one more option, that there was one more set which is possible over here. When your nx and y and z, all of them will become 3. Okay, so 3 square plus 3 square plus 3 square is also going to give you 27. So basically there is one more set of 3, 3 and 3 which is going to give me 27. So there are how many, what is going to be the degeneracy? So the one each set represent one degenerate set. Okay, so one energy set, second degenerate energy set, third and 4. So what is the degeneracy basically? So degeneracy will be 4. So option 4, option 1 is going to be the correct option for this question. All right, let's look upon the next question then. Okay, this particular question was a little difficult type of question, and it just requires the basic knowledge of the topic. Okay, if you know how to find out these functions, then you will be able to write it down. Okay, it says that the spatial part of the dominant resonance structure. Remember, the words are very important here. It says dominant resonance structure, okay, of the lithium hydride molecule is. Now the word over here, dominant resonance structure, plays a very vital role when you are answering this particular question, right? So let me first of all tell you the how this lithium hydride molecule is going to be, and you know that it is highly polar. Okay, it will be highly polar molecule. And if you talk about the polarity or electronegativity of both the atoms, so lithium electronegativity is quite less, it's around 0.96, whereas the electronegativity of hydrogen goes around 2.1. So that means what, hydrogen is more electronegative, and it is going to make this particular bond a very very polar bond. Now when you draw the resonance structure of this, so basically what is going to happen, that these two electrons which are actually going to be the covalent electrons which have been shared by both these atoms, by the lithium and hydrogen, in order to form this particular bond. So this bond will not be totally covalent. Okay, it will be a polar bond. Okay, where the electrons will actually reside on hydrogen. Why? Because hydrogen is more electronegative. So the electrons are going to reside on your hydrogen instead of residing it on the lithium. This is very important to understand, right? So this is going to be the dominant resonance structure. So in the dominant resonance structure, your electrons are going to stay on hydrogen because of the high electronegativity of hydrogen. Now here the values are, the terms are given to you, that R1 is what, that is your distance of first electron from the nucleus. okay, from nucleus, and R2 is your distance of second electron from nucleus, right? So fine, if you know both the things, so that means both the electrons are right now on your um, on the hydrogen atom itself. So that means the correct answer for this particular question will become your option number 4, okay, where it says that R1, that is distance of the first electron from the nucleus, is going to be in the s orbital of hydrogen, and similarly the distance of the second electron from the nucleus is also going to be on hydrogen, okay. So this answer is correct because of the dominant resonance structure. Now let's say if the question was asked where it was not given about the dominant resonance structure. Instead of that, they have just asked about the covalent bond, okay, or about the covalent structure, or they have not given about this particular term. They have just asked about the lithium hydride molecule. In that particular case, your answer would be option 2. Okay, option 2 would be the correct option, because it says that the first electron is on lithium, second on hydrogen, because there both the possibilities would be there, right? So in that case, the correct answer would have been option number 2. Okay, so that is how we will evaluate this particular question, and option number 4 is the correct option. So I guess you guys understood, right? Okay, so let's talk about this question, which says that consider the gas phase reaction where 2 moles of A is reacting with 3 moles of B to give me 2 moles of C at a given temperature. Now it says when 2 moles of A is reacted with 2 moles of B, we are getting 0.8 moles of C at the equilibrium, okay? And the total pressure is given to us as 2 moles. Now they are asking is the value of equilibrium constant for the reaction at the given temperature. Alright. So how to do this particular question? First of all, just write down the equation which is given to you. Okay. So 2A is reacting with 3B, and this is giving us 2C at equilibrium. Now this is like straightforward question from your equilibrium like topic, right? From the ionic equilibrium. So here you can see that we have to calculate Kp, that is equilibrium constant uh, in terms of partial pressures. So let's write down the equation for that. So Kp will be given by partial pressure of C, and the square of that, because the coefficient is 2 over there, divided by partial pressure of A, and square of that, because again the coefficient is 2 over here, and the partial pressure of B, and cube of that. Okay, so this is what is going to be the the equation for Kp. Okay, so let's keep it aside. Now how we have to calculate this partial pressure? Okay, so I guess you know about it, but in any way, if you have to calculate partial pressure of any of the species like A, B or C, you have to multiply with the mole fraction of that species to the total pressure. So total pressure we already know. If we can calculate the mole fraction, we just have to multiply with that, and in that particular case we are going to get the partial pressure. All right. So we need to find out the number of moles. As soon as we will be able to find out the number of moles, we will be able to find out the partial pressure, and then we will be able to put it over here, and then we would have easily, like, we can easily calculate the value of Kp, right? So the number of mole is very important to calculate over here, and that is the whole trick which is going to happen over here. Okay, you have to be very careful when you are solving these type of question. Okay, I'll tell you how you can simplify the things. So let's write down in this way that how many initial number of moles you have. Okay, then what is the change in the number of moles? Okay, what is the change because of the reaction, and then how many number of moles you will get at equilibrium. Now remember, when I am writing all these terms, you only need the number of moles at equilibrium to be used. Okay, rest of the terms are only to evaluate the equilibrium term. Alright, so I've just written it like this. So here I'll be writing for A, for B, and for C, and like that. So initially the number of moles of A is given 2 moles in the question. B is also given as 2 moles, right? And we don't know about C because C is not being used up till yet. So that is 0 moles, because initially obviously C is not being formed, right? Now what you have to do is the change, that how much like change is going to happen. So let's say that C is formed by 2x amount. Okay, so what we are going to say is C is getting formed by a value of 2x. Why I have taken 2x, that is also very important to know, because it's given to as the coefficient. I could have taken x also, and then the calculation would have been little bit more complicated. So in order to simplify it, I've just taken it as 2x. It's pretty simple to do that, right? So in order to form 2x amount of C, how much A do we need? So we need 2x amount of A to form 2x amount of C, right? It's pretty simple. Agar like if how much amount of C you have, you just need that much amount of A to get formed, because the number of moles for both of them is actually same in the equation. So that means the change value is minus 2x. I have written minus 2x, that means it is getting decomposed, or A is being consumed, or it is on the reactant side. How much amount of B you require? So since the coefficient is 3, so for 2 moles of C you need 3 moles of B, right? So that means for 2x amount you need 3x amount of B, and negative sign because it is getting consumed. Now at equilibrium, what is going to be the value of C? So it's already given to you, right? The value of C is given to you as 0.8 moles. So it's given 0.8 moles. Now we already know that we have taken the change for C as 2x. So basically your 2x is actually equal to 0.8. So you can easily calculate the value of x. So the value of x will become 0.4. Okay, what I have done, I have used this change and equilibrium to evaluate and to calculate the value of x. Okay, now talking about the others. So at equilibrium, what is going to be for A? So it is going to be 2 minus 2x, and for B it is going to be 2 minus 3x. If I substitute the value of x here, so it will be 2 minus, and 2 into 0.4 will be 0.8, right? And here it will be 2 minus 3 into 0.4 is going to be 1.2. So for A I am going to get 1.2, for B I am going to get 0.8, and for C it's 0.8. So these are the number of moles actually which we need. Okay, so these are going to be the number of moles which are required to solve the equation further. Now you can easily calculate the terms which are needed. So if I have to calculate partial pressure of C, that can be calculated by number of moles of C, that is 0.8 divided by total number of moles. So total number of moles, let me just write down, because mole fraction actually is equal to number of moles of A divided by total number of moles. So the total number of moles is going to be 1.2 for A, plus 0.8 for B, and plus 0.8 for C. So total number of moles will come out 2.8, right? So here for partial pressure of C, given number of moles of C divided by total number of moles and multiplied by total pressure. Total pressure was 2 moles, sorry, 2 bar, right? So 2 bar for that. So it is going to be 2. So by solving this, you will get partial pressure of C. Similarly, you can do for partial pressure of A, partial pressure of B also. So overall, your equation from here in the numerical form, this equation is going to become, that is Kp is equals to, this is going to be 0.8 divided by 2.8, 2.8 and multiplied by 2 and whole square, because it was Pc square, right? In the denominator, I have PA. PA means partial pressure of A. Partial pressure of A, for that I have to put number of moles of A, so that is 1.2 divided by total number of moles of compound, that is 2.8, and into partial pressure, that is 2. Into total pressure, that is 2, and whole square of that, because I have partial pressure of A square. Similarly, if I have to calculate partial pressure of B, I have to give number of moles of B, which is 0.8, divided by total number of moles, that is 2.8, and multiplied by 2 and whole cube. Okay, so that is going to be the whole thing which we have to actually solve. And once you will solve all these values, you are going to get something approximately equal to 2.4. Okay, so you just need to solve this. So you can just cancel out these powers, you can just multiply, divide and solve, and at the end what you are going to get is 2.4. So your correct answer will become 2.4. I'll suggest you to do the calculation over here. Okay, so try to calculate this, because in exam we don't get calculator, but we should be aware about that, how we can simplify it. So simplifying is pretty simple, you just need to cancel out with the powers over here. So what is left out is nothing but so at the end you can write down that Kp is equals to, this is going to become 2.8 into 2.8 divided by 1.2 into 1.2 and into 4, right, multiplied by this particular term. So this will be 2.8 divided by 0.8 into 2. So that's what you have to solve. So once you are done with it, you are going to get 2.4. Okay, so I guess this is now quite clear to you how to solve this question. Somebody was asking me in the comment section, I don't remember the name exactly, but yeah, this question was something which is needed to be explained in detail, right? Okay, let's move on to the next question then. Okay, the next question which says that the polymer, okay, here the question is based upon the polymer, and it says that the polymer of n monomeric unit, the root mean is square separation between the two ends, it's proportional to. So you are given with the number of monomeric units. Okay, so number of monomeric units, it's given by capital N, and the root mean is square separation between the two ends is being asked. Okay, so to answer this particular question, there is a direct formula. The question was actually asked from the direct formula, where it says that the root mean is square separation, or DRMS, that is root mean is square distance, that is equals to L into under root N. Okay, what are the terms over here? Here L actually tells you about length of one monomer. Okay, one monomer unit. So what is the length of that monomer unit, and n is the number of monomeric unit. So actually this is going to be proportional to, so you can say that DRMS is going to be proportional to n to the power 1 by 2. So the correct option for this particular question will be your option number 1. Okay, this was pretty straightforward directly from the formula. Okay, let's go to the next question then. Alright, for this particular question where it says that for the electrochemical cell, the cell is given to you. This is silver electrode over here, Ag and AgCl, and M is some metal with metal chloride, and it's given 0.01 molar of that you are using. So the junction potential is the highest when M plus is. Okay, so they are asking that when your junction potential is going to be highest. Now to answer this particular question, you just need to know the concept. Okay. So liquid junction potential, I guess we have studied already. Okay, and this is a concentration cell, and this is reversible in cation, right? We all know that particular thing. Okay, so liquid junction potential will be given by the transport number of cation. Okay, T plus, that is the transport number of cation, and RT upon NF, and then you have ln A2 upon A1. Okay, where A2 and A1 are activities of the different sites of the reaction, and this particular part is going to be this is going to be constant. Okay, because the concentrations, because this depends upon the concentration values, so that is going to be dependent upon only upon the concentration. So this particular part is going to be constant. Okay, this is going to behave as constant. So the only thing which is going to change over here, like based upon the ions or based upon different metals, will be the transport number, right? So what we can say that for the given condition, your liquid junction potential is going to be proportional to the transport number. Okay, so that's what we need to know. Now transport number is something which depends upon mobility of ion. Okay, so what we should know, that transport number depends upon mobility of ion. Okay, mobility of ions. All right, now mobility, you know that it depends upon two things. Okay, mobility depends upon two things. The first thing is that charge. Okay, and mobility actually is directly proportional to charge. So we should write down like this, that mobility is directly proportional to the charge. So the higher the charge, the more will be the mobility, and it is inversely proportional to the size of the ion. So smaller the size, higher will be mobility. Now we can see that over here in all the options charge is same, so we don't have to worry about the charge factor. What we have to discuss is the size factor. So what we have over here is, I'm just going to write down all the relationship in a single line. So liquid junction potential is proportional to transport number. Okay, it's proportional to transport number. Transport number is proportional to mobility of the ion, and mobility is inversely proportional to size. For this particular question, this is what the relation is, and that's what we are going to use to solve it. Okay, now you can see that lithium over here, Li plus, is small, but due to more yeah, so over here you can see that there are two ions which are very small. One is lithium and the other one is hydrogen. Okay, so which is going to be our answer? So just based upon size you cannot answer it. Okay, if you will just go with size, we will say that okay, answer will be option number 2, and you will just mark option number 2 as correct. Okay, but that is not going to be the scene. Okay, what you have to know is that lithium ion is very small, but due to more solvation effect over here, it will move along with the solvation ions of the solution. Okay, and which is going to create low mobility. Okay, so what is one more factor which we have to study is the solvation. Okay, the solvation. So solvation should also be small. Solvation effect or solvation power should be small for higher mobility. So here we know that for both these smaller ions, for hydrogen ion and for lithium ion, for both of them, the size is small, but the solvation, what we have to know, that the solvation of lithium plus in aqueous medium is going to be more than the solvation of H plus ion. Okay, so that means solvation is also less, size is also less. So the best metal ion, or the best ion which you can use over here for the liquid junction potential, okay, for the highest liquid junction potential, is your hydrogen ion, not your lithium ion. Okay, so many people did mistake while solving this question in the exam. They did lithium as the correct one, but the solvation effect is the one which is making lithium less favorable than your hydrogen ion. Okay, all right, let's go to the next question then. All right, so now we have a question on quantum mechanics over here, which says that the function which is not an eigenfunction of the indicated operator is. So you are given with the operator, you are given with the function, you have to check that whether that is a eigenfunction or not. Okay, now we all know about eigenfunctions. The equation is like, if you have operator A getting operated on a function psi, and if you are getting some constant along with that function back, that means if you are getting that function back, so that function will be called as a eigenfunction, and the constant which you get along with that is called as a eigenvalue. Okay, so this is what we know. So based upon that, we can just solve this particular operator and function one by one to check whether they are eigenfunction or not. So to guide you a little bit, let me give you a little hint that whenever you have trigonometric functions like sine theta or cos theta, anytime if you get sine in any form or cos in any form, and if you have to do double differentiation, so double differential of that, then they are always going to be eigenfunction. Okay, and I will try to explain you on the further slide. Okay, so just try to say it, that if you are differentiating this, that is d2 by dx square, what does that mean? And you are doing it cos pi x by 4. Okay, so if you are doing that, that means you are going to differentiate twice. So when I am going to differentiate once if I have differentiated, so cos theta is going to become minus sine theta. Okay, minus sine pi x by 4, and whatever the coefficient of x is, that will come in the front of that will come in the product form of that, and yeah, so the pi by 4 will be there with a negative sign. Okay, now again you have to differentiate, so minus pi by 4 will remain as it is, and the differentiation of sine theta is going to be cos theta. Okay, so whatever you have, so cos pi x by 4, and the coefficient of x is again going to come in forward, so pi by 4. So what you are going to get is minus pi square by 16 and cos pi x by 4. Now if you see this, you are getting the function back, right? So you have started from this function and you are getting the function back, so this is a eigenfunction. So this is going to be our eigenfunction. Similarly, for every e to the power x kind of functions, you will always get eigenfunctions. You can check that also. So d by dx square and e to the power 4ix. If you solve this, so once when I will differentiate this, I am going to get the coefficient is going to come forward. So 4I will be as the product, and e to the power 4ix will remain as it is, because differentiation of e to the power x is e to the power x itself, right? So you are going to get the same function like this. Now you can take this 4I outside, so I'll take that, and I again have to differentiate this particular part. So when I will differentiate again, I'm going to get 4I e to the power 4ix. Alright, so this 4I will get multiplied, you will get 16 and I square e to the power 4ix. So basically I square can be written as -1, so minus 16 e to the power 4ix. So you again got your function back, right? You can see that the function from where you have started, you got it back. So that means what? This is again eigenfunction. So this is also eigenfunction. Now we have to check these two. So I'll try to do in the next slide. Okay. So here we have d2 by dx square and plus, sorry, we have first one as minus, right? So minus x square, this is the operator, and we have to operate that on e to the power minus x square by 2, right? So this is what we have, minus x square and e to the power minus x square by 2. So let's solve this. So we have to multiply it inside. So this is going to be d2 by dx square into e to the power minus x by 2 and minus x square e to the power minus x square by 2. So you have to solve this particular term. Okay, so to solve this, I'll just do it over here in short. So d by dx of e to the power minus x square by 2. What will be the value of this? Okay, so just see it. E to the power x has that only value. Okay, so we will use the chain rule of solving it. So e to the power minus x square by 2 will remain as it is. Now you have to differentiate this particular part. So differentiation of this particular part will be minus, and x square is going to give you 2x and the coefficient is 2. So basically you will get what? You will get minus x e to the power minus x square by 2. So this is what you are going to get when you differentiate e to the power minus x square by 2. So that means once when I will differentiate, so d by dx of what I am going to get is minus x e to the power minus x square by 2, and minus x square e to the power minus x square by 2 is what you will get as the other term. So you have differentiated once and we got this. Now here we have to apply the product rule, okay? Because these are the two functions, x and the exponential function. So negative sign I'm taking outside, and when you solve this, so basically you are going to get, like, you are not going to differentiate x, you are going to differentiate e to the power minus x square by 2, and then plus, you are not going to differentiate e to the power minus x square by 2, and you are going to differentiate x, okay, and minus x square e to the power minus x square by 2 is as it is. Now just open the bracket, solve it. So minus, here you are going to get x, and the differentiation of that we have already done, right? So that is going to be minus x e to the power minus x square by 2 plus, okay, and differentiation of x is going to be 1, so plus e to the power minus x square by 2, okay, and minus x square e to the power minus x square by 2. Just open the bracket. So this minus is going to make it plus, so this is going to be x square e to the power minus x square by 2 plus e to the power minus x square by 2 and minus x square e to the power minus x square by 2. Now you can see that this term is cancelling this term. What I am going to get at the end is nothing but e to the power minus x square by 2, which is my function back. So that means what? You have started operating the operator on the function, you got your function back. So this is eigen function. So that means option number A is again a eigen function. Okay, so first option is also eigen function. So obviously three of them came as eigen function, so the one which will not be eigen function will be 2. If you want to check, you can see that the only difference is with the plus sign over here. I will show you how you can understand that. So if you have plus sign over here, you will be getting plus over here, plus over here, plus over here. Okay, everywhere it will become plus, plus over here and plus over here. So then you cannot cancel out these terms. So these will not get cancelled out now. Okay, so since they will not get cancelled out, see, if you have plus over here, so that is going to become your second option, right? So if you have plus, 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 so in that particular case you cannot cancel them up, so you will not get this thing. Okay, so it is not be, that particular part is not going to be your eigen function. So in that particular case, like, they will not get cancelled up, right? Instead of that, they will get added up. So that means what? That your option number 2 is not an eigen function. So I guess now it is quite clear and the solution is complete. So now you can solve each and every like option and you can get to know. Okay, the idea is to tell you that always whenever you have sine theta term or cos theta term or e to the power term and the powers are linear, in that particular case double differential will always lead to a eigen function. Alright, let's go to the next question then. Alright, so let's talk about this particular question, which says that the oxidation of NO to NO2 occurs via the mechanism. Mechanism is given to us. The first step is a reversible step. The second step is a unidirectional step, and it says that dNO2 by dt is in the presence of large excess of O2 can be written as. Now you can do this particular question quite similar to what you have done in enzyme catalysis. So it will be quite similar to that, and how we are going to do, let's try to see. Okay, so we'll apply a steady state approximation on N2O2. Okay, because this is the value which, or this is the species which is there in both the reactions, and this is behaving as an intermediate, very short lived, right? So when you apply that, so what I will get as dN2O2, okay, and by dt will be actually equal to, it will be written like, for the first step it will be k1 and no square, right, minus k minus 1, because now it's on the reactant side, it's N2O2, and here from the second reaction I can write down minus k2, it's N2O2 and N2O2. Okay, so that's what I can write down, and since it is steady state approximation, I can take it equal to 0. Now I have to calculate the value of N2O2. So the value of, so yeah, so how we are going to do now further is, I can take N2O2 common from here. So N2O2 can be taken as constant or common. So I will get k minus 1 and plus k2 and O2. Okay, and on the other side I will be getting k1 and NO square. So basically your value of N2O2 is going to be k1 and NO square, and divided by, it will be k minus 1 and plus k2 O2. Okay, this is what I got. Let it be equation number 1. Now from the given equation, from the given particular equation, if I have to write down the rate of formation of NO2, so here you can see in the second reaction is giving you the formation of that, but 2 moles of NO2 is getting formed. So from the given reaction, what you can write down is your half moles of NO2, in order to form half mole of NO2. So dNO2 by dt. Okay, that's how we write down rate equations. The coefficient comes in the denominator, and that is equals to k2 N2O2 into O2, right? Now if you substitute the value of N2O2 from equation 1, you are going to get dNO2 by dt. I'm taking 2 to the other side as well. So 2, and this from here I will be getting k1, k2 is already there, so k1, k2, and I'll be having NO square and O2, and in the denominator I am having k minus 1 plus k2 and O2. Okay, so that's what I am going to have. Now this is what is going to be the equation for the rate of formation of NO2. Now it is said when the excess of O2 is there. Okay, so for excess of O2, what is going to happen, that over here my this term, that is k2 and O2, this particular term is going to be very much greater than your k1. So you just have to neglect this particular part. Okay, you have to just neglect this particular part. So you are going to get d NO2 by dt, that is going to be equal to 2 k1 k2, and in the numerator I have NO square, NO square, and you have O2, and in the denominator you just have this term, that is k2 and O2. Now you can just cancel out few of the terms, like this O2 will be cancelled out by this, k2 will be cancelled out by this, so you are going to get 2 k1 and NO square. Okay, so this is going to be your final answer. So the rate of formation of NO2 is going to be given by 2 k1 NO square. Okay, so that is going to be the correct answer for this. So option 1 will be your correct option. So this is how you have to approach this particular question. I hope this is much clear to you. It was very simple, very straightforward question. There was nothing difficult in this. Let's take the next question for this video. Alright, now this particular question is from group theory and it's basically from your character table. It says reducible representation lambda in the table is equal to the following superimposition of irreducible representation for C2E point group. A1, A2, B1, B2 are given to you, and the reducible representation is given to you. They are asking about the irreducible representation. Okay, they are asking just about the is equal to the following position of the irreducible representation, means they are asking about the irreducible representation, right? So how we will do, so we'll calculate, you know, all that how we calculate it, right? In case you don't know how to solve character table, how to find out reducible and irreducible representation, I'll be giving you link over here of one of my video which is highly watched. You should watch that video too if you don't know about that, so you will just get an idea. In very short, I have explained that how to use character table to find out all the important properties of the particular point group. Okay, so let's calculate for a1. So that will be equal to 1 upon h will be 4 over here, and in the bracket I have to multiply the term, so 1 into 8 plus here it will be 1 into minus 2, so plus it will be 1 into minus 6, so plus, and it will be 1 into 4, so 1 into 4. So if I calculate this, I am going to get 1 by 4, and here I am going to get 8 minus 2 minus 6 and plus 4. So that means what, um, like 8 and this 8 are going to get cancelled out. You are going to get only 1, so you are going to get 1 a1. Okay, so a1 will have a coefficient 1, so that means option number 3 you can cancel out. 3 is not going to be your answer now. Now let's do it for a2. Okay, so for a2, so lambda a2. So for a2, when you will do for a2, you are going to get what, 1 by 4. 4 is the class, so let's write down that. Then for a2, so 1 into 8, so 1 into 8 plus, now 1 into minus 2, so 1 into minus 2 plus, this is minus 1 into minus 6, so minus 1 into minus 6, and then minus 1 into 4, so plus minus 1 into 4. So overall you are going to get 1 by 4, it will be 8 minus 2 plus 6 and minus 4. Okay, so this 4 and 2 will be 6, so they are going to cancel out this 6, you are going to get 8, so you are going to get 2a2. Okay, so a2 will be 2 times, so now you can cancel out option 4 as well. So either option 1 is correct or option 2 is correct. Now you have to check the other term. Let's check for b1. Okay, so when we will do it for b1, so we'll be doing it for lambda b1, and that is going to be equal to 1 by 4, and in the bracket I'll be having 1 into 8 plus minus 1 into minus 2 and plus 1 into minus 6 plus minus 1 into 4. Okay, so that's how I'm going to get. On solving, I'll be getting 1 by 4, and here I'll be getting 8 plus 2 minus 6 and minus 4. So 8 plus 2 is 10, and 6 plus 4 is also 10. So this will cancel out each other, so you are going to get 0. So b1 will not be there in your term. So now you can cancel out option 1 as well. So the correct option for this question becomes your option number 2. You can check out for b2 also. If you want, you can check it out. We'll get 5b2. So in that particular case, your correct answer or your irreducible representation will be equal to a1 plus 2a2 and plus 5b2. Okay, I have not done for b2, but obviously if these three are not correct, so fourth one will be correct. So like that, we have done 10 questions in this particular video. As I told you in the starting itself that I'll be splitting up the solutions in 2 videos. So this is the first video of the solution. I'll be posting the second video very soon after recording it. For now, this is the only, like, this is the solution, and rest of the questions from part C will be uploaded in the next video, right? So I hope you guys understood all the concept. I hope you guys liked the video. I hope you understood and you enjoyed whatever I have taught. If in case you have any doubt, you want to ask anything, you can ask that in the comment sections below. And if you have any suggestion, if you have any request, that also you can drop that below. And thank you so much for watching, guys. If you are new to this channel, do subscribe to the channel, give the like to the video, share it with your friends, and keep studying and stay safe and stay at your home. So thank you so much for watching. Have a great day. Bye bye.